Hello and welcome to another Solana tutorial. This is Dev Course Module 4 Part 2. Today we're gonna talk about PDAs yet again. Yes, because important topic and we have not talked about it enough yet. Besides, it's one of those things that is key to understand for writing Solana programs. If you have an understanding of PDAs, basically you can do most of the things. Or let's put it the contrary, if you don't understand PDAs, then you're pretty much screwed and you can't really work efficiently with Solana. Because they are so essential to the data layout and, structuring your data and accounts and everything. They are important, let's put it like that. So let's dedicate yet another video just on this. Today we're gonna talk about PDAs, reminder what they are, and I'll give you some use cases what to use them for. Here we are. So we're gonna once again explain what a PDA is or what PDAs are. We're gonna explain various use cases of PDAs. There we go. Yes, that's the important thing here because we already talked about PDAs back in the deserialized custom account data lesson. So that's module 1 part 5. That's why we also talked about them. So to get an intro, you can look back to this. However, today we're going to talk about it more from a program's perspective. So not from the client side, where I need to also, know the seeds to be able to derive the address, but from a program side, how the program structures their PDAs in order to have a nice data layout and whatever. We're going to describe in detail how PDAs are derived. So we're going to have a look how that works under the hood. There's some hashing there. Essentially, you hash the seeds and then boom, you have a PDA. We use PDA derivation to locate and retrieve data. Yes, that's the actual use case then, because the data is within the data field of an account, which address is derived by the PDA, right? Okay, let's do it. A program-derived address, PDA, is derived from a program ID and an optional list of seeds. This is just a reminder. This is nothing new. We have already discussed this. So every PDA has one specific program ID, and that program ID is then able to sign for that PDA. And for one program to not only have one PDA, you can add some seeds, which is essentially just a list of bytes. And if you provide different bytes, you get a different PDA. But if you provide the same bytes, you get the same PDA. That's the entire idea here. So PDAs are owned and controlled by the program they are derived from. Yes, so owned, I don't actually 100% agree on this because they don't need to be owned by the program. James, correct me if I'm wrong. I can derive a PDA and then set the owner to a different program. That's what the associated token program does, right? The associated token program creates a PDA for a token account that is then owned by the token program. So yeah, it doesn't need to be owned. In general, it is owned by the program itself because then it can also write data to it, but doesn't need to be. And controlled in the way that I am allowed to sign for this. So I have the authority for this account. I can sign for it and therefore transfer Lamperts out. And theoretically, I can write a PDA and then make it owned by someone else. I can do that, sure, why not? PDA derivation provides a deterministic way to find data based on the seeds used for the derivation. Okay, slowly. A PDA provides a deterministic way, so always the same, providing the same seeds will give me the same PDA, deterministic, to find data. So, first we find the account and the account can hold data based on the seeds used for this derivation. So based on the seeds, we will always find the same PDA, so the same address, and with that we will always find the same data, or the same reference, the same data. Seeds can be used to map the data stored in a separate PDA account. Now that's very cool. And that's the main use case for PDAs, in my opinion. You create a map, right? So with different seeds, you get different PDAs, and therefore you can create this key value relationship and basically create a map because the PDA seeds are a set, and then behind each of those addresses, you can find some data, which is the value. So we have the key value. Yeah. A program can sign instructions on behalf of the PDAs derived from its ID. So the program can sign, and only the program which's ID has been used to derive this PDA, it can sign on behalf of this PDA. So essentially saying, this is my account. I have the key for this account. Because for PDAs, remember, there are no keys. It needs to be off the curve. So there are no private keys, but the programs can sign. That's such a neat thing. Such a neat setup. Like the more I work with it, the more I appreciate it. Anyway, maybe I'm just highly biased because I've never worked with anything else. Hashtag solandy. Okay, overview. Once again, what is a PDA? They are account addresses signed for by a program rather than a secret key. So yes, no secret key, you can sign with a program. And it's derived with that program ID and a set of seeds. And why do we use those PDAs? To provide a deterministic way to find an address for a program-owned account. So if I want to always have the same address, I just always have to provide the same seeds and it will give me the same address. And more importantly, that the program can then also sign for it, because obviously the program cannot like store a private key because it's all public on chain. So there needs to be a mechanism how the program can actually prove I signed this. This is my account. I have the authority for this. And that is done with PDAs. Right, and here we will focus on finding and storing data. And we will talk once again about PDAs when we do CPIs. Yes, cross-program invocations, not consumer price indices. Deep dive into how do we actually get such a PDA. They're not created, they are found or derived. Based on the program ID and some input seeds. I think I said it enough times now. You need the program ID and the input seeds. Right, so Solana uses this ED25519 elliptic curve, and it's a deterministic signature scheme that we use to generate the public and private keys, right? So private keys, use curve, public key. And a private key and the public key together are called a key pair. So, that's how we get our key pairs. We come up with our private key and then we find the corresponding public key using this elliptic curve. Now, we can go the other way around and be like, this is a public key, and then check if there is a private key for it. That's what we do with PDAs. So essentially we create a random public key and then check that it's not on this curve. Therefore, there's no possibility that a private key can map to this address. And to find such a PDA, we use the find program address function that again just takes a list of seeds and the program ID. Who would have guessed? And then it returns the PDA and the bump. Now we also already discussed what a bump is. Essentially, when we do lie on that curve and there is a private key for it, well, we just add a byte to our list of seeds and then change that byte until we find a point on the curve where there is no private key for it. And if you use this find program address, then you already always have this bump seed starting with 255, and you decrease it every time it's still on the curve. But that we have already discussed. Now, so in Rust, it would look like this. It's again in public key, the find program address function, and you give it a list of seeds like this. It can be strings, or it can be like public keys or any kind of byte sequence making up this entire list, and then the program ID, and you will get the PDA plus the bump in return. Having the PDA and the bump, you can just use create program address. That will not do the whole thing with the bump, but we're jumping ahead here. So let's talk about seeds. So they are optional. You can have an empty list here. It's a valid sequence to create a PDA, but without any seeds, you will create one PDA for one program. Obviously, you might want more, and then you just, put in some seeds. Just one byte, and boom, you have a different one. Change the byte, a different one again. So you have 256 more PDAs. And then you're like, I still need more. And then you add another byte. Or you just, start with the few bytes and use something that is, more speakable, like vault or treasury or whatever. And again, those seeds can be anything. They can be public keys, they can be just some user input or hard-coded values like this. Point is, they will all just be smushed together into one list of bytes. So to the find program address, it doesn't matter where those bytes come from, whether they come from a public key or just some static string or something that the user has input. It's all just put together. So please note, even though you separate them here like this, it will just be one list. So if you theoretically have two user inputs right after each other, you can't tell where the first one stops and the second one starts. So if you had like two user inputs like this, and the first is Andy and the second is 1, 2, 3, that will give me the same PDA as if I were to put in Andy 1 and 23. Because the bytes will be the same. Just something to think about when constructing those. Anyway, I'm going into the details again. But I find that important, and that's why I mention it as soon as it comes to my head. A PDA can also be derived using only the program ID, no additional seeds. We said that, but if we have seeds, we can have an arbitrary number of accounts. Yes, indefinitely, essentially, because we can just make the list of seeds longer. I mean, at some point you'll run out of addresses, but before you run out of addresses, you would have to use a lot of addresses. I mean, this is essentially how this is secure. You will not be able to create that many addresses that you find the same one again. That's the whole premise of this being secure. Practically, you will never run out of addresses, only theoretically. Okay, where was I? While you, the developer, determine the seeds to pass into the find program address function, the function itself provides the additional seeds called the bump seed. Yeah, so the find program address will add another byte, which is the bump seed. Since we are on the curve about 50% of the time, and we need it to be not on the curve, that's why we need that bump seed. We just discussed that. But the important thing to remember is the bump seed is just added at the end of the list of seeds. Here comes the bump seed. So if we want to sign with this now, then we need to use those same seeds plus the 1 byte bump seed at the end of it to derive the same PDA and then sign for it. And that bump seed, as already discussed before, starts with 255 and then is decremented every time it's still on the curve. Good, let's look at this under the hood, what's actually happening here. So if we have a look at the source code of the find program address, oh, you don't see where my mouse is, so this is pointless. If we have a look at the source code of the find program address, it essentially just does try find program address and then unwrap or else panic unable to find viable program address bump seed. So for the case that all of the 256 possibilities for the bump don't work, this will panic here, I assume. Which practically is never going to happen. Because, I mean, the likelihood for that is 256 times a half. I mean, a half to the power of 256. Yeah, that's how probabilities work. So rather low probability. Right, so what does the try do then? It introduces the bump and it iterates. So the bump seed is the U8 max, so 255. And then for 255 times, it decreases the bump seed for 1. So we're essentially having a loop. Here we count up and here we count the bump seed down, where we just push the bump seed to the list of seeds. So again, at the end of the list of seeds, we add the bump seed and then we call the create program address. And this returns as an option. So if we manage to get an address, then we return sum, the address and the bump seed, and otherwise invalid seeds. No, wait, the error is what we get back from the create program address, and then nothing happens and we continue in the loop. That's it. First, yeah. So if we have invalid seeds, we do nothing and we continue in our loop with the next bump seed. And only if we went through the entire loop, then we return none, which is, the none in the option, and then we panic. Right. So if we have invalid seeds, we just continue with the next round. So we decrement the bump. Boom. So what does create program address do then? That's where it gets interesting then. Essentially, it performs a set of hash operations over the seeds and the program ID. They compute a key. And then we just need to check if it's on the curve or not and give the result accordingly. Because this thing returns me a result. So that's the okay or error. An option is just it has some or none. Rust basics, remember. So let's look at this. We create ourselves a hasher, a default hasher, whatever that is. And we put in all the seeds. I don't really know how this hasher works. Should I look at it? Let's just accept that this does the hashing. And we add the seeds. And then in the end, we hash v. No, I do want to find out what this does. Returns a SHA-256 hash for the given data. Aha, okay. Point is, we put in all of the seeds, so all of the bytes, and then add the program ID and the PDA marker, whatever that is. Hey, I can look at that source code, right? Why not? Create with seed, give me the source. Let's look at this here. Maybe the implementation has changed because it's different to what James is showing us. Find program address, this thing. So there's another implementation for it. So it is more complicated, but the essential part is here. If we're not running it on Solana, if the validator runs it, then apparently they need different code or something. I don't know. So we have a hasher, we add the seeds, and then we add the program ID and the PDA marker. And my question was, where does that come from? It's just yet another static seed program derived address. Okay, that's it. Just another PDA marker. Yeah, because you can, that's why. Program derived address. So even if you don't provide any seeds, there is some stuff that is being hashed here. Back to this. Once we added the program ID and this program derived address, static seed, or static marker, then we retrieve the hash. So that's a SHA-256. And then we just check, is this point on the curve? So this hash. If it is, we return an error. Invalid seeds, because the create program address doesn't do anything with bump seeds. It just takes the seeds, and if it's on the curve, it says nope. And that is then handled here, right? That's why we do nothing here and continue with the next iteration. And if it is not on the curve, we say, okay, here's the pub key. So we just create a new pub key from this hash. So the hash, those bytes, again, 32 bytes, SHA-256, 256 divided by 8, just to prove my maths, is in fact 32. Wow! So we have 32 bytes for our public key that we just put in here. And bam! I have a public key. Great. That's it. That's how you get to a public key from a list of seeds and the program ID. To repeat, find program address, just inputs the program ID and the seeds to the try find program. Could happen that there is no bump, and calls the create program address to actually derive this PDA and then checks if it is a valid one, and if not, continues with the next one and otherwise returns. Cool. So same input seeds can have different valid bumps. That's also true because a bump is just yet another byte that we add to the seeds. So that's where the canonical bump comes in. That's just the largest possible bump or the largest valid bump. Is that right, James? It will always return the first valid bump. Yes, because we, in our loop here, we start with the max value and then we decrease. And this bump is commonly referred to as the canonical bump. Yes. And to avoid confusion, it's recommended to only use the canonical bump and to always validate every PDA passed into the program. Obviously, you can pass in any address when you call a program instruction. And if you expect it to be a certain PDA, then it's good to double check that it's actually that PDA. Yeah, another thing that is obvious for me, but might not be so clear to everyone, the find program address only finds the program address. It doesn't actually do anything on chain yet. This is just a hashing function. It's just giving you the PDA. It doesn't actually create anything yet. It does not initialize any account. And it also doesn't mean that there is an account already there with that find program address. It's just finding the address. It's not finding an actual account and checking if there's an account on chain. This is different. You need to get account info for that. Right, now to the actual use cases. Using PDAs, PDA accounts. Yep, that's how you say it. Program derived address accounts to store data. Accounts which address is a PDA. Boom. Okay, we've gone over this many times. Programs are stateless and we can only store stuff in accounts, not in the program itself. And because we can use those seeds, it's just common practice to use PDAs to store our program data. It's extremely common design choice, yes. It's just convenient because we need to store it somewhere, and the alternative is to somehow remember the account address, and then the user has to pass that in every time. That's possible, but it's way more convenient to pass in just the seed, derive the PDA from it, and then know where the data lives. If you need a refresh on how to store data, have a look at this tutorial. Yes, we did that. I'll link it here, up there. Now to the way more important, interesting thing, creating a map. Map data to store in PDA accounts. Because storing data is only the one way. We also need to read the data, right? So we need to retrieve it. We'll talk about two approaches. Creating a PDA map. So James wants us to learn. So in this first approach, we just create one PDA map where we store the addresses where the various accounts are located, right? So we create yet another PDA where we just have our map of accounts, right? We say the treasury is here and the token vault is here and whatever, right? And then in the second strategy, we'll use the seeds to locate the appropriate PDA accounts and retrieve the necessary data. That's what we want to do. That's the nice design choice, just using the PDA seeds themselves as the key for our map. So first, the stupid example. That's a lot of text. So in this example, we might want to be storing notes for users in our program. So we have one program and then we have several users, and each user can have several nodes. So all those nodes are stored in an account because, we need an account to actually store data. Program itself can't store anything. Cool. So we need an account for each node. Now, where do we find those if we want to retrieve them? Well, we create some kind of mapping for it. And again, we will write where we find those nodes into another account. So we could just have one big account. Global mapping is the one seed for it. We derive it with global mapping. Then we have one account where we have all of the mapping for each user. So essentially, in here, you would store a list of lists, right? Because you need to be able to serialize it somehow. And the first list contains the users. And then for each of the users, we have another list with all of the nodes of the user, right? And whenever you create a new node, additionally to writing the node account, you also write an entry into this global mapping. However, there are several disadvantages to this. One being, if there's just one account with all of the data, then that's a bottleneck, because every time you create a new node or every time you do anything, you need to pass in that account to the program, so it will not be able to run in parallel anymore with another call to the same program. And more importantly, you will eventually just run out of storage space, because one account can only have 10 megabytes at max. I mean, you can get quite a few addresses in there. For an address, you need 32 bytes. You have 10 megabytes. So yes, quite a lot, but it doesn't scale indefinitely, right? Besides, it's really unnecessary storage that you are wasting here, because you could do much better. But before we get to the ideal solution, let's look at how we can make that a little bit better. Let's keep this global mapping, but add another mapping for each user. So in the global mapping, we would just have per user one entry to one other address. And in that other address, we store the list of nodes per user, right? So I create a separate account for each user. So in our global mapping, we look up where's that account for this particular user. And then we look into this account, and there we see, oh, those are all the nodes for this user, and I can retrieve them. scales already better because we now can have 10 megabytes worth of users, and each user can have 10 megabytes worth of nodes, like 10 megabytes divided by 32 bytes in nodes. But this is still kind of unnecessary, because what do we do in this global mapping now? Well, we have for each user, we get yet another address. For each user, we get an address. Wasn't there something that we can do with PDA seeds? Yes, we could put that user address as a seed for a PDA, and that will return me that address. So I don't need to store that address somewhere. I can just use the user ID as the seed for a PDA. And then we can get rid of that global mapping and do the same for the individual nodes. So each node could also be part of the seed, and then we get a PDA from that. But let's look into what James actually says here. So that would be then the second strategy, using the seeds to locate the appropriate accounts. Let's see what James says here. So we get rid of this global mapping, and instead, for each of the nodes, we use the user, so the initializer, key, so that's the public key, the 32 bytes from the key, to find the PDA. And then we can also add the title of the node, such that we have also this mapping. So for each user, they can have several different nodes, and the title is what makes the node unique. Why did I do that? I have no idea. So as long as the title is different, you can store a different node. Now the disadvantage here is to retrieve the node, you will need to know the title. So if you don't know which nodes the user published, then it's hard to find the correct PDA for it. You would need to work with get program addresses, but that's not good. Like in that case, it might even make sense to make one account per user to have a list of all their nodes. Might make sense in some cases. A different strategy, if you don't want to know the title in advance, is to just use an incremental number here, right? So we have node 1, node 2, node 3, and just, have 4 bytes, AU32 that you increment for each node. Then the retrieving is also simpler. Or you keep it with the title. And that's just design choices. This is just something that you need to think about. What do I want to do? If I just want to write them, and when I edit them, I know the title, and when I retrieve them, I know the title, then this approach is great, because you just create one account. It might make sense to store all of the nodes of a user somewhere, but really it depends on what the use cases are. Anyway, main point here is we can use the keys or anything that we know up front to create the PDA, and then have this mapping. So a key maps to one account. With this title in this example makes it way more complicated than I wanted it to be. So let's make it one step simpler. If each user could just make one node, let's forget about several nodes. Each user can just make one node, because there are examples for that. Each user just has one token account. Each user just has one vault. Then instead of creating such a global mapping where you store this is the user, this is the node account, you just put the user's public key into the PDA derivation and make that account on that address the node account. So you have the mapping to use the user's public key to then find the account you're looking for. Does that make sense? Because that's important. And then of course, you will have more complex things, like when every user doesn't have just one thing, but they can have several, but they usually depend on something else, right? They usually have one per something. So each user per token has an associated token account, for instance. And that's an example here, the associated token account address. We can see that's derived with the wallet address of the user, so each user, and then the token program ID per token program, and then the token mint per mint gives me one PDA. And again, if the token program makes it too complicated to grasp this at first. There are different token programs, so we need to put that in there. But let's assume there was just one token program, then we could leave that out. And we say every user for every token has one specific address that is the associated token account. Or coming back to this node example, let's say we allow users to write comments on a given node. And again, we'll just allow one comment per user to make it simple. Then we could just use the user itself, the public key of the node of the different user. So let's say user B wants to make a comment on the node from user A. So we'll just use the node from user A as one of the seeds. So that the address, the public key of that account, we use it as part of a seeds and us ourselves. So user B, the key, and with that we derive an address. So then we also have this mapping. Per user, per node, you can make one comment. Does that make sense? It is really such a simple concept and you just need to grasp it once and then you get it and you're like, PDAs are great. We can just make a mapping. Anyway, the associated token program does exactly that. It uses this functionality from finding a PDA to create an associated token account. Now, we did discuss this in the lesson about the token program. So module 2, part 1, what an associated token account is. Essentially, you want per wallet address, you want one account for a given mint, because you can have different ones that are then called auxiliary token accounts. But if somebody sends you something, they should always send it to the same account to avoid creating a new account every time, because that makes stuff just complicated. That's why we introduced the associated token program. And essentially what that does with the get associated token address behind the scenes is just finding a PDA. And the seeds for that PDA are the wallet address itself. So for which wallet this token account should be created. The token program ID, because different token programs could theoretically have the same mint address, and there are different token programs out there. Token 22 has a different public key than the normal token program. So we put in that as a seed as well, and the token mint address. So what token we create the associated token account for. So that would be, the address of, USDC or whatever. And with those three seeds for the program ID of the associated token account. Associated token program? Anyway, there's a special program just for this. Associated token program. I just type A and it finds it. Great. So the A token GP. That's the program with which ID we find this. And then that pub key that is returned there, usually we give it to the actual token program to own it, because it then changes it. Yeah, and essentially this gives us a deterministic way to find one token account for each wallet, for each mint, for each token program. The mappings between those seeds and the PDA accounts will be, of course, highly dependent on what your program is doing. And now this isn't a lesson on design or architecture, but the basics. You should use seeds that are already known at the time of the PDA derivation. Obviously, if you don't know what you derive with, you can't derive, right? So something that is only calculated after the fact is really bad as a PDA seed. So use static seeds, just some strings, use public keys of other accounts or wallets that are known before the fact, and use user input as desired, right? So if when retrieving that, you will also know that input again. Then be thoughtful about what data is grouped together into a single account. Ideally, one account stores one struct of data that belongs together, like one note or one entry in the movie review thingy, or one NFT metadata, or one token account amount and mint and stuff, right? So the token program also does it like that. There's not one big account for each user where all of the tokens the user has are stored. No, there's one per mint. because that belongs together. And simpler is usually better. Don't make it overly complicated. Be thoughtful about the data structure used within each account. That just means when serializing/deserializing how you store that data. And we discussed that in previous sessions. Stuff like put the variable length things at the end and think about what you need to store. Do you want to store the bump into the account as well, which is good practice? Yeah, and what information do I need to store and what can I infer from the derivation of this path? All those things. It's a lot. But the point is, really all I want you to take away is you can have such a nice mapping of key to value just using PDAs. That's all the theory. Now let's actually look at that in practice with our nice movie review program, because we haven't worked with this in a while. Oh, and now we're gonna do it locally. Haha! In this lesson, we will build and deploy locally. Nice. But you already managed to get through the important part. If you're not interested in me going through the demo, you can essentially stop watching here. That's totally fine with me. But if you want to follow me, stick around. Let's get the starter code from here and get ourselves an IDE. We clone this. Git clone. And we have it all locally. Now let's check if my REST analyzer does something here. There we go. And REST analyzer is analyzing. Perfect. What we gotta do? Open the folder, run cargo build BPF to build the program. See, that's why we prepared this last time. So we run cargo build SBF. Damn it. Oh, of course I need to go in the movie review. And then what? Oh, and then this. Yes, okay. That's looking better. Yes, let's do it. I mean, it says it compiled this. Yep, we have a PDA local.so. PDA local. That seems to be, that seems to be the program name. Yep, PDA local. So looking good. Start the Solana test validator. There we go. Such that we can now deploy Solana program deploy, and then I think we need the SO file, right? But how does it know the key? Let's do that. Okay, and somehow it got the key file, so because that's now my program ID. Perfect. So program is deployed locally. Let's get the front end for this as well in yet another console. Let's continue. Plan out the account structure. Previously, we finished implementing the ability to update the movie review in a secure manner. Yeah, that was the last thing we did. In this demo, we add the ability for a user to comment on a movie review. Okay, so that's what we're doing. And we'll use this as an opportunity to see how to structure the comment storage using PDAs. Yay, PDAs! Adding comments means that we need to make a few decisions about how to store the data associated with each comment. Criteria for good structure are not overly complicated. If it's overly complicated, it's never good. Data is easy retrievable, so obviously we want to find the data again. And each comment has something to link it to the review it's associated with. Yeah, okay, so if we have a comment, we want to come back to the review. To do this, we create two new account types: comment counter account and comment account. So apparently we will do this with the counter approach. As mentioned above with the nodes, I can either have, the list of all my comments, or I just make a counter and count through them. But then if I delete a comment, that doesn't really work well with the counter. So everything has advantages and disadvantages. So you always need to think, what do you want to do and what is the use case for of that. So there will be one comment counter per review and one comment account per comment. Well, that makes sense. The comment counter will be linked to a given review by the review's address as a seed. That makes perfect sense for finding the counter PDA. For finding, okay. It will also use a static string comment as a seed. The comment account will be linked to the review in the same way. However, it will not include the comment string as a seed, and will instead use the actual comment count as a seed. So, I could have just another static seed here. I could have comment counter for this one and comment for this one, something like that. But here we just use the number of the comment as a seed. That way the client can easily retrieve comments for a given review by doing the following. Read the data on the comment counter to determine the number of comments on this review. Yep. And then when we have n comments, then we do this n times, and in each iteration we will derive the PDA and retrieve the address of the comment, and for each of those we can then access the account. That's step 3. There we read the data, we fetch the extra accounts and read the data for all those n PDAs. Well, so far so simple. npm start, and if we check localhost port 3000, oh, because it's still compiling. There we go. But now let's go. Come on. Yes, here we go. Okay, I'm updating this because I was too harsh. Spider-Man. Okay, so obviously we don't use A, our local setup, and B, our program. So let's change that there in the form. Okay, so we want our program. That's what we're gonna put here. And then also the connection, use connection. Okay, that we just need to set with a wallet. Okay, so let's save this. This is recompiling. Then we go here and we refresh that. And we should get an empty list, I guess. No. Was the program already here? U to local. Airdrop us 10 sol. Easy. That's how I like it. And we have 10 sol. If I airdrop me 100k, I airdrop myself 100k. This is... I'm rich now! This is fun. Anyway, all fake money because it's just local. But anyway, so cool. I have that local thing set up. Question is still, why does that show me stuff? Because I did change the address here. Maybe I also need to change it somewhere else. So in the form and in the movie coordinator, I need to change it. Okay. And then if I compile this and then I refresh this, there we go. That's what I expect. No reviews here. Okay. Now let's create one, and is YouTube video. So that's not working. Probably because the recent block hash doesn't really fit the whatever recent block hash from here, because they're probably on a different network. See, there are just some little things that make this, and we're not even developing anything. We're just trying to set it up. All right, okay. So let's search for, I don't know, DevNet. Endpoint, there we go. LocalNet, local. Okay, you know what? Then you get this. Compiling, compiled successfully. So that is now in wallet context provider. Refresh this. Connect. Okay. Still. Oh, but now we get more. Failed insufficient account keys for instruction. Interesting. But it already got here, it locked the title, it locked the rating, it locked the description, but we can already call our program. So that's already a start. Come here, look at the actual process. Ah, probably one of those. Insufficient account keys. Yes, probably one of those throws insufficient account keys because you can't get a next. So we don't have the initializer PDA counter and system program. Yes, because PDA counter and those we don't provide them. Okay, so makes sense. All of that still works. But then my question is, do I also need to change the front end now? Or am I not on the right? Make sure you use the solution update reviews branch. I think that's where I am, right? Specifically went to that. There, solution update reviews branch. Yeah, because the movie review doesn't exist yet. Ah, this is complicated stuff. Maybe we also need to update our front end accordingly. But then the question is, why do we start with this here? Maybe I'm here on the wrong branch. Hold on. Should I have started on a different branch here? On the starter branch, of course. I think I just already have the solution here. So if we... Sorry, my bad. Yeah, we're on main. Hehe, okay. Yeah, then we don't check out this starter. That's better. Okay. Build SPF. Solana program deploy. Programs authority. Oh, I deployed earlier with a different key. Let's deploy again. That's what happens if you don't have the right authority and you try to update your program. Now, with that program and that stuff, can I now submit a... Yes, that looks much better. Okay, cool. Yes, transaction submitted. Perfect. And then if we refresh this, it should hopefully also list it as a movie review down here, which it does not. Solana confirm this, and then with dash V. Yeah, there we go. So that's a success. Rating, description, cool. Unpacking state, So that went through. Don't ask me why it's not showing this here in the movies down here. Doesn't matter. Let's keep going because we need to make some progress here. So cool. So this is what we want to do. Now this ensures that every one of our accounts can be deterministically retrieved using the data that is already known ahead of time. Yay. Now we need to do the following. Define the structs to represent the comment counter and comment accounts. Yeah, we need to say how they look, what data they have. Update the existing movie account state to contain a discriminator. Movie account state, because we want to distinguish between movie accounts and comment accounts, because otherwise there could be a mix-up. There's an attack for this. I just heard it in a security lesson. It's called account confusion. So if you pass in an account, you want to check that it's actually of that type. Anyway, that's security stuff. Add an instruction variant to represent the add comment instruction, and then implement this add comment, I guess. Yeah, create a new add comment instruction in the processing, and update the existing add movie review to include the creation of the comment account. Okay, yeah. Let's start with those structs. We do that in the state, a movie comment counter, and a movie comment. Yeah, the discriminator. Now that we have multiple account types, we need a way to only fetch the account that we need, because otherwise the program cannot check which type of account was passed in. It can be a movie account, it can be a comment account. And I mean, for this movie and comment, it's not that bad, right? But if you're working with like vaults or stuff, like if you're working with actual money, you don't want them to be confused. If the one thing stores the owner and the other one at the same location just stores I don't know, the title, then theoretically somebody could write in the title the owner of the other one and then pass that in as the other account, and essentially faking the authority. And even if you do owner checks, that's not sufficient, because both of the accounts belong to our program, but we need to check that it's actually of that type of account. So that's why we need that discriminator. That should actually be more in the security lesson than in here, but we're now talking about it. So yes. Cool, let's do this. I will try to do this from how I would do it, and then we check how James did it. So in the state, we have so far just the movie account state. Okay, so here we add a public discriminator, which I would put as a U8, because I mean we have 3 types of accounts. We just need to distinguish between 3 so far. So 1 byte should be sufficient. And the rest we leave the same. And then we do the same thing for a comment account state, where I would put a title. Where I would put the discriminator definitely. And then, well, what does the comment need? Well, like a text like this. The writer, the guy who wrote the comment, the writer of the comment, the owner, the author of the comment. And if it's initialized, I mean, I guess we can keep that flag in the comment as well. Although I would probably just remove it and just create comment accounts if they are already initialized, and not have comment accounts created that were not empty before. So only if I can create the new account, then I will write anything. I won't do any updating on it. So anyway, and then the other thing, movie comment counter. So the comment counter state, I would just use the discriminator. Do I want to store the movie itself inside the comment counter? I mean, for it being nice, I could, but really all we need here is like a counter, which is a, I don't know, U32. So that's all I would write in a comment counter. And then, I mean, if we have it like this, actually, I would put this thing directly in here in the movie account, already store it there, because one movie account will always have one comment counter, so might as well put this thing in here. But we want to learn how to use PDAs, so we keep a separate account for it. And maybe a movie doesn't have any comments, then we don't need that account. So yeah. So that's how I would do it. How does James do it? Note that we add a discriminator field to each struct. The discriminator is a string that can be used to filter through accounts when we fetch our program accounts. A string, James? Really? You would do that as a string? A string is variable length. Then you're completely effed if you want to do some offset. Like if I want to read just the review of it and I have a string that has different length for this discriminator and this discriminator. I mean, theoretically, I could still, because I know the discriminator, I can still use the fixed offset because the discriminator will always be the same. But still, I kind of don't like having a string here, to be honest. But it's okay. It will work. It will work. So the movie comment counter also just has the discriminator with an is initialized and a counter. Okay, the counter he uses U64, which is fine. I mean, I don't intend to write so many comments, so U32 is okay for me. And he keeps an initialized bool. Yeah. And then in the movie comment, he stores more stuff. He stores, if it's initialized, the review. Oh yeah, which review it belongs to, so that we can also find back from the comment to the review. That makes sense. That makes sense. I would in fact take that into mine as well. Which review that actually was. We should store that. The commenter, so that's my author, and the comment itself. So that's the commenter and comment in James's layout. And the count. Okay, so here he stores at which count that was. Okay, again, to be backward compatible probably, or to be, if I have the movie comment, to be able to find my own address. I guess, why not? Let's do it like James does, and also do this. And keep it identical to what he does. Okay, cool, good. And the is initialized, he also implements for those two. Fine. Now he just has different names than me. Oops. Fine. Not very consistent with the account state. I would then also call this movie counter account state, but F consistency. Okay, since we've added the discriminator field, the account size calculation needs to change. We'll add an implementation for each of the three structs that adds a constant discriminator. Right, that I will just copy, I guess, because I've not seen this. So we have a discriminator for each of them in our implementations. And here we have review, here we have counter, here we have comment, and there we already know the length of this. So this is the string length 4, because string has variable length if you serialize it. So the first 4 bytes are for indicating how long the string is. So we have 4 plus the actual length of the discriminator, plus, in this case, 1 byte, 32, 1 byte, and then variable length. So 1 byte, and then those two variable length. James, aren't we missing the reviewer here? I think you are forgetting to add the reviewer here. Anyway, movie counter, same thing, 4 plus discriminator length, plus 1 plus 8, because 1 and 8, that's easy. And for this one, same, then plus 1 for is initialized, plus 32 plus 32 for those two public keys, and then again a string and 8 bytes. So that's the string and 8 bytes is initialized. We have the two public keys for review and commenter, and then we have the actual comment and 8 bytes for the counter. That's this. Here the initialized and the counter, and here I think we are missing the public key. Just saying. I'm just gonna copy this because I don't feel like doing a typing exercise. So we implement some more stuff, a static string. And in my opinion, really, we're missing a plus 32 here. I'll just put it in. Maybe I'm wrong, but better have a too large account than a too small account. Cool. Now everywhere we need a discriminator or account size, we can use this implementation and not risk unintentional typos. Yes, so obviously you don't want to always have to type this, but you want to actually use that discriminator thing from the movie comment dot discriminator. But I guess there is a typo in here. Create the add comment instruction. Yeah, I mean, and it's just gonna take one string, right? So what our comment will, there it has the comment and is initialized, we'll set it to 1. This is static. This will set to true once it's actually written. This and this we get from the accounts. So the accounts that are provided in the instruction. And this is the only thing that we need to pass in as instruction data. This we also read from the movie comment counter, which is again an account that is passed in. So the only thing we need to put in is the comment. So in the instruction, we add a add comment, which just takes a string comment. Easy as that. Then what do we need to do? Probably add something like this here with the 2, probably add comment, where the comment is payload dot, where do we get the payload from? More review payload. Well, I would just recycle this and use the payload description. No, I can't, because it has a different layout. So in that case, I would need to do a different try from slice with just a comment, and movie comment payload is just a string. And then we can't use the same payload because we can't try that anymore. This is getting more complicated. What does this try from slice? If I don't provide the remaining data, then this will fail. That's a problem. How does James do that? He also does a separate payload. Yeah, and then he needs to do that separately. He does that as well. Okay, we gotta do it like that. So we need to make another layer around this and be like, this payload goes here, and here we have a different one. Here we have the comment, movie comment payload. All right. Oh yeah, and then it's payload.comment. Cool. Then we update the process instruction in the processor. Okay, processor, you now complain about this instruction. Why? Because it's non-exhaustive, because there is the add comment as well. Yes, so we need to add this here. And not only do we need this, but we also need the comment count and movie comment. And then here we can also have a movie instruction add comment with the comment. which should map to just an add comment with all program ID accounts and then comment. Now, where do we find that? Where do we find that? Well, we need to make a function add comment like this, like this, just with add comment. And instead of all that PS, we just have a comment. And then we need to implement this. Did I do that right, James? I think so. Cool. But that was all just like housekeeping, restructuring stuff. The actual interesting part with the PDAs, losing my head, is coming now, hopefully. Oh no, first we need to update the add movie review to create the reviews comment counter account. Okay, so already in add movie review you create that. Then my question still is, why don't we just put it into the movie account itself? But I don't judge. We just, because we want to try out how to do things with PDAs. That's why. It's so counterintuitive to me why that has comment as a seed. I mean, comments, okay, but comment? It's your layout. I trust your layout. Nah, I judge your layout. We could also add counter. We could also add a counter field to the original movie review. Thank you, James, for pointing that out, because I'm like, why don't we just do that? Because design choice. That's why. We want to make it complicated for ourselves for no apparent reason. So in the add movie review, let's add a PDA counter. Haha, and that's what was causing the issue in the front end then. Okay, so if the account, if without title and description, our length, so the account size is greater than 1,000, then we should give an error. How did we do this until here in the add movie review? First of all, here we have another one, PDA counter account. Is that what he called it? Just PDA counter. There with the length. That length. Okay. Let's replace this. We also need to update the update movie review, but I'm too lazy for that. I just don't update my reviews. Once we've initialized the movie review, we also need to update the account data with the new fields with specified in the movie account state struct. So mainly that means here account data discriminator to be from movie account state discriminator. Does that already work? No kind of weird referencing? James still has a toString. I'm not sure if I need that. Expected U8 found string reference. Oh, right. My discriminator was still a U8 and James wants it to be a string. Okay, fine. Let's have it a string in all of them. Okay, expected struct string found reference string. Okay, that's probably why we need the toString. Yes. Okay, good. Now, just for fun, I want to see if that already compiles, because you kind of gotta do that sometimes. So here, just say okay, just give you a okay, just so you don't complain anymore. And then can I compile you? Oh, there. Yes, I have some warnings. Yeah, because that's not used and that's not used, but that's okay. All the warnings just tell me stuff is not used. That's perfectly fine. That's perfectly fine. But it does compile. Okay, cool. Okay, it compiles. Good. Moving on. I mean, the analyzer does make it a bit harder to read, actually, but pretty sure you can configure that. So let's add the logic to initialize the counter account in the add movie review by calculating the rent exemption for the counter account, deriving the counter PDA using comment as a seed, invoking the system program to create the account, set starting counter value, and serialize the account data and return from a function. Now that is the relevant and interesting part. So that's what I'm gonna attempt to do alone again. So once we've serialized this account, we will also attempt to create a separate one for the counter. So essentially, I'm gonna copy this unpacking state, this, and this. Oh, this is gonna be confusing because it's a lot. Let's do step by step. We start with, actually I would start with a PDA because the user can pass in anything here. So I should do a double check that that is the actual PDA as we learned in the security lesson. But then again, the system program create account will fail if I don't sign for that anyway. The only bad thing that could happen is that the user provides a non-PDA account and then I create that and signs for it. So one with a private key and signs with that private key. And then I create that account and then I have a mismatch with my PDA and that. So I should really check for that. It's good practice. Let's do it. Let's do it. Let's do that check. As we did up here as well for this one. So that's for comment counter. C count PDA. I'm not interested in the bump seed. We find it with our program address and the seeds are, what do we need? The review and comment, right? So I would go the PDA account key and the movie comment counter 2 bytes probably. S bytes, not 2 bytes, S bytes. S bytes. So that's how I would do it. Possibly even the other way around. First that and then that. That's how I would do this. And then I would check that it's the same as the PDA counter key. Otherwise, we have an invalid argument. So that's checking that the PDA was provided correctly. So we have the PDA checked. Okay, then we need to figure out rent. So let's say C rent, because I'm lazy. Anyway, so the rent, I don't need to get that again. I can say rent minimum balance for the counter length. And this we get by get account size, because that's static. Let C length be movie comment counter get account size for C length. Okay, so that's for rent. And then we can already call the system program. We call the system program with our initializer. So that's the one who pays. PDA counter is the key. Then C rent lamperts. Then C length try into unwrap. And the program ID, that's the one who owns it. Perfect. And we sign it. We provide this as an account and we provide the signer needs to now be the same. Okay, now we need the bump. So we say C bump. We need the bump and we had the discriminator and the PDA. So we had the, I'm just going to copy this from up here. Discriminator and the PDA. James probably chose some different ones or a different order. We will have a look at that in a second, but that's how I would do it, right? So that's system programs, system program instruction to create this. Yeah, and then we can already try from sliced, check if initialized, and write the data and serialize again. All of that, except not for the account data, but for the comment data, PDA, counter, sorry. Counter data, counter account already initialized, and then we say counter is movie comment counter discriminator to string. And what does that actually have? Initialized and, oh man, now I need my Rust analyzer again. The what title? No, bullshit. You are not a movie account state, you are a movie counter. There you go. See, without the Rust analyzer, I would not have done that correctly. And this I set to 0, I guess. And then serializing counter account is I just write this to not the PDA, but the counter. I think that's good. Should we check how we did? Let's check how we did. So we calculate the rent with minimum balance, movie, comment, counter size. Or did we have a fixed size for this? Oh yeah, we did. Movie, comment, counter, we have a size. What did I use? Ah, see, that doesn't even exist because it's supposed to be size. Because it's fixed length. Then counter and counter bump with, okay, so here he has the PDA as reference. So yeah, that's the same. Wait, I used PDA account.key. Yeah, that's the same. Cool. And then the comment, yes, other order. I had the comment first and then the PDA, but that's fine. It gives a different PDA, but it's the same. This or this. Different PDA, but then again, always the same PDA. So it will also work the way I did it, so I'll leave it the same. Except on the client side, I would then also need to change it. So, okay, let's not leave it the same. Let's do it the James way and put it the other way around. Put the discriminator after this, just so I don't have to mess with the thing. And then this looks good, and this looks good, and this looks the same. Hey, James, you said such that we don't have typos, and then you don't even use the discriminator here? Listen to your own goddamn words. Now everywhere we need the discriminator, we can use this implementation and not risk unintentional typos. Mark your words, James! Anyway, it also works like this because obviously it's the same. I'm not even sure if I'm doing it correctly because here is comment as ref and I have the string as bytes. But this is just bytes. It will be fine. Then try from slice, movie, comment, borrow, unwrap is initialized. There we put in the discriminator. Did I put the right discriminator? Because if I copy stuff, then I always movie, comment, counter, discriminator. Sounds good. Data 0, initialize true, and then we serialize it out to this PDA counter. Perfect. Now that's, I think, correct. Now, when a new review is created, two accounts are initialized. The first is the review account, and the second is the account that stores the counter. Could have put it in one account? Yes. Did we do it? No. Do we care? Nah. To be backwards compatible, okay? Is 6 already last point? No, but 7 is. Okay, let's finally implement the add comment. To create a new comment, we will increment the count on the comment counter PDA and derive the PDA for the comment using the review address and the current count. Okay, start iterating through accounts. This part I'm still gonna copy because that's the boring stuff. We just read the comment counter. Also, before you do that, you should check that A, we are the owner of this comment counter, and B, it's an actual comment counter account. James is not doing that. So in our add comment, let's put this here. I don't like those. This is just making my screen too full, but you know, whatever. We should assert that, and we should do that for all of them. We didn't. I'm just gonna remind you that you should do this. You know, the PDA counter, program ID, and also the review and the comment. Well, the comment, we don't own that yet. We just create that, so we don't need to. And then maybe something like the commenter is a signer, maybe. That could also be a cool check, just so not anybody can. But it's like, I'm not sure if that's so important in that case, but I want the commenter to be the actual signer of it. So not everybody can just create a comment and pretend they're someone else. Owner checks, signer checks, and then of course account type checks, like counter data is initialized, that's the one thing, and counter data discriminator is. Can I do a direct comparison between strings? I don't know. Maybe I'm doing this wrong, but like something along those lines you should definitely check. See, that's why I would just use a U8. That would make it so much more easy for me. Having a U8 and an enum for account types, not having to compare strings, but whatever. Whatever, we do it the James way. It's okay. I would just use a U8. Anyway, those are checks that I would recommend that you do. And then we can continue with the remaining steps. Calculate the rent for the new comment account, derive the PDA, invoke the system program to create that yet again, and set appropriate values to the newly created account, serialize the account. So once again, the whole steps that we just did, just the derivation will be different now. I'm just gonna copy what I just did down here while finding a typo. Haha, classic. See, that's the problem if you copy stuff, then you're not doing it right. So I will refactor this to comment data, which will be a movie comment. And we read that, okay, so comment PDA, comment bump, find program address, and the seeds will be now. What do we say the seeds are? The review address and the current comment count. So current comment count is counter data dot counter. So we get that, and we say after that, so I'll do it in 2 steps to make it very obvious. This we increase by 1, and then we want to serialize that out again as we did down here where we had the typo, just to make sure that is actually stored. Oops. So that here, and the, where did we have it from? From the PDA counter. PDA counter. Okay, perfect. So that's good. So we get our current counter, we increase it by 1, write that out to that account, and then we can use that current counter. So as the seeds, we will use the current counter, 2 little endian bytes probably, and then the review PDA, so the PDA review dot sref. No, wait. The key of this one, sref. Yep. Expected a slice, found an array of unknown length. Should we just try into? I guess that will work. Yeah, so those are my seeds for the comment. Now we check again that this comment PDA is the PDA comment.key. Then the length, comment length, comment rent is the movie comment. This will have a get account size for the comment, and rent. Did I get that up here somewhere? No, here we need to do a new rent. That was just with rent get something something. There, rent get. And then we can say rent minimum balance from that comment length. And then we make another system program instruction. We create the PDA comment with those amounts of lamparts and this amount of length for that program. I pay for it. This is the address that you take, and then you need to sign. In order to sign, we need to provide the seeds as the program. So once again, we take the same seeds as here. Da 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 da. Boom, and the comment bump. Easy. Then we have the, oh, we don't have an initializer. How did we call it? We called it the commenter. Okay, fine. Oh, what's happening here now? Called it the commenter. Okay, the try into might not be the right thing then. A slice, haha, because it's an array and we wanted a slice. Let's just do that. I have no idea how to Rust. And there's a lot of red, but it's okay. And then once we have the system program instruction sent and it comes back and doesn't fail, then we can do movie comment from PDA comment borrow, comment data, comment account already initialized, and then we say we have a movie comment discriminator initialized true, and then we just write the comment is the comment. We're just slow. The commenter is the commenter key. What else do we need to write? The count is the current count. What else? It has a dot review. Should not have a dot review. Don't tell me I left you with a review comment. You have a review. Oh, review. Oh, of course. Yeah, the review itself. Hey, not the reviewer, but the review to link back. Yes. Let's keep the review. That's the PDA review key. And here, I guess I need to dereference that. Could that be? Yeah. And what here? Use of moved variable comment. Oh, I already put that somewhere. No. Damn. Where did I put it? Where did I move it? Get account size for comment as reference. How does Rust work? But that fixes the issue down here, right? Yeah. Now I can use the comment. Well, then if you need then I can just clone it. But that's like inefficient. It would be much better if I just provided the reference here. But anyway, let's clone it for now just to make it work. It's not very nice though, but also we clone here, so whatever. And that I think should be it now. Then we write the comment data out to the PDA comment. Classic PDA comment data, of course. Constantly overwriting the wrong accounts. I'm definitely some copy paste error somewhere. That would be me saying I did it. Let's see if I actually did. Hold on. Calculate the rent. Yes. Derive PDA. Yes. Invoke system program. Yes. Set appropriate values to newly created account. Yes. Serialize the account. Yes. Okay. How did we do? Let's make a quick comparison. We load the counter. We get the size from comment.clone. Okay. So he also just clones it here. Okay. Fine. Have the rent minimum balance for that account length. Then we get PDA and bump with a PDA review key and the counter data counter. How does he do it? 2 BE bytes as ref. He uses 2 BE bytes. Dude, why big endian? How does that make any sense? Solana does everything in little endian and you just use big endian here for your... I'm not gonna complain, James. I'm not gonna complain. You can do it as you want. You just need to do it the same on front end and on back end. So I need to change it to BE because I can't be bothered to change the front end. Must admit, I would prefer little endian because in the like Borsche also per default uses little endian and it's just nicer because anyway, no, it doesn't matter. It's just a design decision. If you use big endian, you can use big endian. Perfectly fine. It's just a question, where do you put it? You put it at the first byte or at the last byte? Because we have 4 bytes and, if you have number 1, where do you put the 1? The very first or at the very last? So anyway, big endian is nicer to read as a whole thing because then it's at the very right. Well, that's your right. But little endian is used as a standard at Solana, so I kind of try to always use little endian everywhere, then it's less confusing. Because some things, like for instance, the counter that is stored in here, this will also be serialized as little endian. So then using big endian. Anyway, design decisions. It's James's decision to do it with big endian, so we do big endian. I'm just not even gonna complain. I'm not complaining. I'm just making a scene here for you to learn, right? Not for me to complain, but like I'm just making points. I'm just saying little endian is the standard that we use in Solana, in the Borsche at least, if we serialize that out. You can also deserialize your instruction data differently, but again, standard, as far as I know, is we just use little endian. So I don't quite get why we have big endian for this seed, but we do. We just do it. We just do it because we can. So big endian bytes, bam. Let's just do it. And then we try a movie comment from the PDA comment and call it comment data. I even called it the same. Yep, movie comment data, comment, perfect. Check it if it's initialized. At least that check he put in, but it's like not one of the most important ones, just saying. Where does he do the increment? counter data counter. He doesn't increment here yet. He does the increment. Oh, down here he does the increment. Okay, I did that before, but that shouldn't matter. Increments the counter, and here we have PDA, those as refs, the comment itself, initialize is true, and then we serialize it out. Kind of looks good, this thing to string, kind of. I think I did well. I think I did well. There's one last point. Build and deploy. Yes, yes. Let's see if it builds. No more coding, more building. Solana movie program. Cargo build SBF. Uh-oh, title string. We don't use the title of, where is that? Update mover. Oh yeah, because I didn't update the mover review. But why does it not use the title? It should at least use the title in the find program address, no? Initializer and account data title. Okay, because it reads it directly here from the title. From the account, I mean. Yeah, whatever. And then we deploy. Solana program deploy. Boom. Damn it. Oh, because my thing restarted, I don't have the validator running anymore. So let's start the Solana test validator again. And I guess I need to airdrop myself some stuff again first. Or maybe not. Maybe it stored the thing. Oh, what did I do? Build. Deploy. There we go. Boom. Okay, we have that program again. Program again. And I think I just changed the front end to support this, right? I don't want to build any front end. We deploy it with Solana program deploy. You can test your program by submitting a transaction with the right instruction data. You can create your own script or feel free to use this front end. That's the Solana movie front end in solution add comments. So we just check out solution add comments now. In utils constants ts. Okay, let's do it. So in this front end, we say git stash, and then we say git check out the solution add comments. So now we're in the solution add comments, and yeah, now he put it in a constants because I think it's used at 2 locations. Find all references. Yeah, there are many references to this now. Anyway, we just changed this to our program ID, save this, npm run def this, see if that compiles. Compiling. I mean, that looks okay now. Let's see if I refresh this. Aha, now I have a select review to comment. So first we need to make a review. Oh yeah. Oh, 0x0. Haha, that's just insufficient funds. Oh no, that's the account already exists. Insufficient funds is 0x1. Did I already make one with YouTube stuff? Already in use. Yes, apparently we already created this one. But the search doesn't work. For some reason I can't find my... That was the problem that we had in the beginning as well, right? I can't list the existing reviews, even though they're probably somewhere there. But if I have a second, this should now... No, also not. Invalid program argument. Invalid seeds for PDA. Ah, damn. Okay, so we still have a mismatch with the seeds somehow. Well, let's look at this then. Because the ones that we created are not actually reviews. They won't actually have review as a discriminator because they were old accounts that don't have that. So that's okay that it doesn't find that now. But the question is, why can I not create a new one? Because the PDA doesn't match yet. Okay, where does that with the PDAs thing happen? There. Movie, serialize, public key, movie title, and then the counter is PDA to buffer. Oh yeah, wait, no, I did put it that way. PDA to buffer and then comment for the movie review program. So I calculate the E6N and my program calculates a 6J something. Strange. One more time. Let's compare those two. PDA counter, PDA to buffer, and comment. And here we have PDA and counter. Because it's something completely different. Nah. That's why James uses the discriminator. Okay, remember about like an hour ago when I complained that James was like using comment as ref and not the discriminator, and I complained about it. Well, it's because it's something completely different. It's something the discriminator is what we write into the account, and this is what we write into the PDA for derivation. But see, that's exactly the point for why I would have also called this counter or comments or something else. But comment for the counter is just super confusing in my head. Anyway, it should be comment. Of course it should be comment. Sure. So we just, instead of this, I mean, we could use the movie comment discriminator, which is comment, but no, that's just stupid. Because that's the counter video. But that would work then. Just to prove how ridiculous that is, that would work now. God damn, this is stupid. Absolutely freaking stupid. But okay. I'm not even gonna complain. I'm not complaining. I do not complain. He makes... Would still fail. At least it fails because of something else now, probably. But yes, we now fail cross-program invocation with unauthorized signer. Yeah. Of course, because I just changed it up here and down here where we sign for it. We also need to change it. Again, this is just being stupid. We should totally not use that constant, but have a comment or define the comment as a different constant somewhere else. PDA static or some BS like this. Submit again. Ha! That looks much better. Okay, now we can create it. There we go. Now it works. But it's so stupid. So fucking stupid. Anyway, great. We were able to submit this thing. Does it now show here as a comment? As a review? Still not. Yeah, there we go. Still the wrong way around for some reason. Don't ask me why. But whatever. Max seed length exceeded. I didn't even send a comment. Send. Does nothing. Okay, let's look at those errors, damn it. Max seed length exceeded in movie TS. Yeah, because he's mixing up the title with the review again. Don't ask me why that happens. Because this time I just used James's code, not even mine. And this is too long of a title. Okay, let's create another one. This is... I think I made the whole thing unusable because this is too long now. So, but hey, there we learned something. You cannot provide indefinitely long seeds, apparently. This will give you an error. Max seed length exceeded. Hey, but this is still in the title. Okay. Short. That should work. Because here it's still derived with a title, but then it's weird. Something is weird with this. I don't even want to try and understand. This is serious about PDAs, not about whatever. So if I now click on that, so can I now, because this is short, this is hopefully also the review not exceeding my, because it now has that as a title. So it had the same thing, so maybe that should work now. Anyway, this is messed up. Just saying. Please connect your wallet. I am connected. Oh, try that again. Super weird. This will fail, but this is now, let's see, comment is super weird, and then invalid seeds for PDA. So also with that other PDA, we were messing something up. Okay. So we have invalid seeds for PDA. Let's check those as well. See, that's the thing with PDAs. It's like, they need to be exactly the same seeds, otherwise it's not working. In the processor, in my here add comment, I derive the PDA with current comment count 2 BE bytes and then PDA review. Now S slice, does James also do that? I didn't double check that. How did he do that? He did that PDA review and then counter 2 BE bytes as ref. Okay, So I already see it. He first has the PDA and then the counter, and I first have the counter and then the PDA. So obviously that is not gonna give me the same goddamn PDA. So we gotta change that. When I checked my code, I was not actually paying that much attention on the order. But order is important, because otherwise it's a different PDA and then I can't sign for it, and then it will give me that. So I changed it here, and I will also change it here as ref, which probably does the same as slice. I'll keep it with as slice just to check if that also works. So, okay, if I send it now, haha, now it works. Look at that. Boom, I can make a comment. Yes, nice. Yes, that also works. Yes, nice. Okay, cool. And then I close this, and then I click on this, and then it retrieves the comments as well. Yes. Okay, I'm done. It's good. It's good. It's working. Keep in mind that we made breaking changes. None of the reviews will be on this front end due to data mismatch. We saw that. Okay, yeah. I recommend that you go check out the solution code and then challenge yourself and do the same thing with the student intro program. Once again, because that's the thing that you do yourself. We do it together with the movies, and you do it by yourself with the students. Essentially almost the same, but different project. There's also the starter code here, and then you have the solution down here. Can't scroll further down. Yeah, I hope that you learned something today. This was getting longer than I hoped. One more time, but that's usually the case with James's development course. I would say we're done with this. Next time, we'll talk about cross-program invocations. So make sure you subscribe, like, and watch other videos if you haven't watched them yet. And then I see you in the next video. I'll see you in the next video. Peace out.